On this lesson, we'll be discussing how to properly solve trigonometric equations. So let's get started. Let's look at this introduction question. Well, in here, it states how many value of x's will make the following equation true. So here's our x. But this question is asking us, what degrees can I plug into the sine function such that my outcome is exactly 1/2? Well, notice that 1/2 is one of those values that we do have from a unit circle. So perhaps it will be a good idea for us to look at our unit circle. And remember what we're looking for. We're going to be looking for angles that if we plug into the sine function, it gives me an output of 1/2. So let's look at our unit circle now. So here we have our unit circle. And again, we're looking for angles that will give me an output of 1/2 when I plug into the sine function. In other words, from a unit circle, we're looking for angles that have a y coordinate of 1/2. And notice that we have one here on the 30 degrees, because recall that sine is a y value. So sine of 30 degrees is 1/2. And also from 150, because the sine of 150 it's also 1/2. So notice that we have two possible degrees, 30 degrees and 150 degrees, because they both give you an output of 1/2 when we evaluate it on the sine function. So here we have two possible solutions. So x could have been 30 degrees, or also x could have been 150 degrees. But now, are these the only possible angles that will make this equation a true statement? Well, notice that we're not being given any restriction whatsoever. So we have, in other words, infinite amount of solutions from here, because notice that here are two possible solutions. When we come back to our unit circle, if we start at 30 degrees, let me actually give a color for it. So if we start at 30 degrees and we make a complete circle, if we go around our unit circle, or in other words, if we add 360 degrees, we're going to come up to the same output. So notice that also 30 plus 360 degrees, which is exactly 390 degrees, it's also another solution. But also, if we would have gone in another circle, if we would have added another 360 degrees, so 390 plus another 360 degrees, which is equivalent to 750, that's also another solution, because if we would evaluate the sine of 750, that will still give me 1/2. And notice that we can continue doing this for a very long time. If we go in another circle, if we add 360 degrees to 750, we would get another solution. And if we add another 360, we would get another solution. And if we would add another 360, we would have got another solution. So notice that we could have got infinite amount of solutions from here. And also this is not just for 30 degrees, because we also say that 150 was one of the solutions. So also we could have done the same idea for 150. So I know that 150 is one of my solutions. So therefore, if I go in a full circle, okay, well, don't know why the pen's not working, but 150, if we go in another complete circle right here, we would have got another solution. So let's just write that down. So another possible solution could have been 150 plus 360 degrees, which is equivalent to 510. So here we have another solution. And I know that 510, if I make another complete circle, I could have got another solution. So to 510, if we add 360 degrees, which is equivalent to 870, we would have got another solution. And notice that we can go and find infinite amount of solutions. We can do this all day. So how can we summarize this? Well, notice that in the problem itself, we're not restricting ourselves to any domain. Then we pretty much have infinite solutions. And how can we write them down? Well, One of the solutions is starting by 30, and if I add multiples of 360 degrees, and again, this is multiplication. This is how we can write down all those possible solutions starting from 30. So 30, if we let n equals to 1, I'm just adding 360, which we know is 390. If we let equals n to be equivalent to 2, then we have 360 times 2, which is going in two full circles. If we let n equals to 3, then I'm saying I'm going to start at 30, and I'm going to add 3 circles and so forward. So this is how many solutions can we get starting from 30, and we can do the same for 150. So notice that we have infinite amount of solutions. The only condition is that we're looking for angles that we plug into the function, it gets me the right hand side. That's how you want to think about solving equations when it comes to trigonometric functions. So now that we kind of have an idea as to what do we mean by solving an equation, which means we're looking for angles that if I plug into the function, it gets me what's on the right hand side. Let's actually look at a little more complicated examples now. Let's start by looking at example A. Again, solve the following equation, but now notice that we have a restriction now. Now we don't want to say, well, I can go in full circles. I just want to find out values that are between 0 and 360 degrees. And again, I guess from here forward, I'm just going to write down everything in terms of radians. I guess just for the introduction, I set it all equivalent to degrees, but notice that here my restriction is in terms of radians, so therefore my solution should be in terms of radians as well. So how do we solve equations whenever there's a trigonometric function involved? Well, the first thing that you want to do is make the equation equals to 0, which it already is. And your second step is to isolate the function. So we want to isolate the function sine of x. And how can we isolate the function, or how can we make the function be by itself? Well, the first step is to add 1. So if we add a 1, we have 2 sine of x equivalent to 1. And again, we're looking and we want to isolate the function sine of x. So notice that sine of x has been multiplied by 2. So we want to let sine of x be by itself. So I got to limit this 2. This 2 is multiplying, so therefore I should divide. And now notice that this is kind of like the same example that we have previously on our introduction problem. We want to find values of x. We want to find degrees that if I plug into the sine function, it gets me 1/2. Well, we know 2 of them. Let me see if I can erase all this. Oh, no, erase is not working. Cool. We know 2 functions. We know 30 degrees was one of them, which is pi over 6. And also, we know that 150, if I take the sine of 150, that's 1/2. So I'm going to write as 5 pi over 6. And notice that these are the only possible solutions that we got here. Because here, so what happens to 390, 750, and 870? Didn't we say that there were solutions? Well, now notice that we're restricting ourselves to just one full circle. This is what I mean by restricting ourselves. Because another possible solution could have been pi over 6 plus a full circle, which is 2 pi. But notice that if we do this, that would be 13 pi over 6. Notice that 13 pi over 6 is way beyond 2 pi. 13 over 6 is definitely more than 2. So 13 pi over 6 is beyond 2 pi. So we don't take it in consideration anymore. So notice that how important it is to also take a look at those restrictions. Because we know that there can be infinite amount of solutions, but we don't want to write down solutions all day. So we're just going to say, look, we're just going to keep our answers to the first full circle. All right, so that's the idea behind solving equations. But how about example B? Well, again, the first thing that you want to do is make the equation equal to 0. So let's add the function on both sides. That cancels out. So now we have sine of x plus sine of x plus square root of 2 equals 0. But now that one sine of x plus another sine of x, that's equivalent to just two sines of x's. All right, so we have properly let the equation be equal to 0. So now what we want to do is we want to isolate the function now. Let's isolate the function. So to isolate this function, the first thing that I want to do is subtract pi over square root of 2. So now we have two sines of x equals negative square root of 2. We want to isolate the sign, so therefore I need to divide by 2. So now that we stop right here, we ask ourselves this question. So what degrees can I use such that if I evaluate to the sine function, it's equivalent to negative square root of 2 over 2? Well, for that, let's look at our unit circle. We're looking for angles that if I plug into the sine function, it gets me negative square root of 2 over 2. So where will they be? That's positive square root over 2. But notice that sine is a y value, so perhaps it would be better for us to take a look at the third and second quadrant. I'm sorry, third and fourth quadrant. So here we have one possible. Here we have one possible, which in this case, note if I take the sine of 225, that's equivalent to negative square root of 2 over 2. So we have one possible solution. X can be 225, which in this case we're going to write as radians, so 5 pi over 4. Because again, notice that if I evaluate sine of 225, it gets me negative square root of 2 over 2, because recall that sine is a y value. And there's also another possible solution here, 315, because notice if I take the sine of 315, it is still negative square root of 2 over 2. So here are all the possible solutions, because if I take the sine of 5 pi over 4, it is negative square root of 2 over 2. And if I take the sine of 7 pi over 4, it is negative square root of 2 over 2. All right, so let's take a look at a more complicated example, such as example C, because now we're introducing expressions that have a second degree, and also we're not just talking about one function, because now we're talking about cotangent and cosine. So how can we deal with problems of this form? Well, the strategy doesn't change. Let's start by making the equation equals to 0. So to make the equation equal to 0, I'm going to subtract 2 cotangent of x to both sides. That cancels out. So now we have cotangent of x, cotangent square, minus 2 cotangent of x equal to 0. So now let's stop right here because we have two different functions. I have cotangent and cosine. So how can I solve equations of this form? Well, one thing that you might have noticed is that this is one big term. And this is another big term right here. So this equation is made out of two terms. But notice that the first term has a cotangent. The second term has a cotangent as well. So perhaps we can factor out a cotangent because that's an expression that both terms have in common. So if we factor out a cotangent, notice what we're going to have. If I factor a cotangent on my first term, what's going to be remaining is just cosine squared of x. Because there's a cotangent times cosine squared, that's my first term. And in the second term, if I factor out a cotangent, what's going to be left is just a 2. So what have we done? All that we have done is isolate the functions, because now recall that we have one of those rules that you never want to forget about algebra, which is when two expressions are multiplied and they're equal to 0, you can set each expression to be equal to 0. And now we can solve them properly. Now we can solve them properly. And I'm going to continue my solution here on the right hand side because I think I might need some space. So again, we're going to ask ourselves the following question. And again, they're going to be solved separately. So let's solve the cotangent function. So what value of x, or what degree that if I value it by the cotangent function, it's equivalent to 0? Well, it might not be so straightforward, just like we have sine and cosine, because it's an introduction question, so we want to use our unit circle. Well, recall that cotangent is cosine over sine. So notice that it is sufficient just to say if my cosine of x is equivalent to 0, it doesn't really matter what's in my denominator, because 0 divided by any expression, it is equivalent to 0. So therefore, pretty much, we're going to be looking at our unit circle to see when is the cosine of that angle equivalent to 0. So let's see where in my unit circle is a cosine equivalent to 0. Well, recall that cosine is x. So we can definitely have 90 degrees. So at least for our first expression, we have 90 degrees, which is not going to write as 90, but just pi over 2. Because notice that at pi over 2, the cosine is 0. And 0, in this case, is going to be uh, cosine over sine. So 0 over 1, that's definitely 0. And is this the only way, and is this the only place where my cosine is equivalent to 0? Well, not true, because also at 270 degrees. Because notice that a cotangent at 270 degrees, in this case, it's going to be cosine over sine. So 0 over negative 1, it is definitely 0. And note that these are the only two possible solutions. So we have two solutions coming from cotangent. But now, let's take a look at the cosine function. We still got to do some more work here. So let's isolate the cosine. So let's start by just adding 2. So now we have the cosine square of x is equals to 2. And again, we want to isolate the function. We still have a second degree. So what we want to do here, let's take the square root. And now we're going to have cosine of x equals the square root of 2. But don't forget about this. We have plus and minus square root of 2, because when you take the square root, we're looking at plus and minus square roots of 2. So now what we want to do now is see, well, what angles of x's can I plug in such that my cosine is equivalent to square root of 2 over 2? And at this point, there should be a red flag coming up, because what exactly is the square root of 2? Well, we don't know the value exactly, but I know that the square root of 2, it's approximately 1.41. So therefore, there is no value of x that will give me a value of 1.41. Why? Because if we kind of remember the function of cosine, uh, cosine always starts at the amplitude. Cosine behaves this way, where the amplitude of cosine, it is 1. So therefore, when it comes to cosine, the highest value that I can get is 1. And the lowest value that I can get is negative 1. And notice that here we're looking for a value of x. So some value on the x-axis that can give me an output of 1.41. But I know that the highest that I can go is 1. And the lowest that I can go is negative 1. And definitely 1.41, it's somewhere beyond the graph. So therefore, there is no value of x. There is no value of x that can give me an output of plus or minus square root of 2, because the highest output that I can get is 1, and the lowest output that I can get is negative 1. So keep that in mind when you're looking for angles. If you're looking for an angle that can give you an output that is higher than 1 or negative 1, we just cannot have it. So in this case, x, there is no solution for this x. So what's my conclusion? So my conclusion, well, my only solutions, are just the ones that I got from Code Engine. Because I know two solutions from here. The second half didn't give me any solutions. So if I take all solutions in consideration, my only possible solutions are just pi over 2 and 3 pi over 2.